Case number 29. We are to check or verify this given identity. 1 over secant x minus tangent x is equal to secant x plus tangent x. So we're going to apply necessary operations and equivalence for secant x and tangent x in such a way that we could arrive with an identity, or both sides will have the same expression. Now here we are going to examine later if it's okay to only manipulate left hand side and arrive to the right hand side. But if it's complicated enough, we can actually opt to simplify both sides of the equation. Let's start first with our left hand side. We have here 1 as our numerator over, you have here secant x and tangent x. Secant x can be expressed as the reciprocal of cosine. So we have here cosine x minus our tangent x is sine, okay, sine x over cosine x. With this, we can actually establish here that we could combine our denominator since they both have the same denominator of cosine. This could be equal to 1 over, so you have here the combination. So we have the same denominator of cosine x. So your numerator will just be 1 minus sine x as well. Okay. So with that, notice that our end goal is secant x and tangent x. There's no way for us to come up with this that will result to secant plus tangent x. But we can simplify this further. Just for this, using the keep change flip method, we know this is 1. Okay, so we can flip, or we can use the keep change flip method, retain or keep the numerator, change the operation to multiplication, and your denominator will be flipped. In short, you will have here cosine x over 1 minus sine x. Okay. This would mean the final form of the left-hand side would be 1 over, sorry, it's not 1. It is cosine x, okay, all over 1 minus sine x. Now, cosine x here nor sine x can no longer be expressed as simpler form further, and we cannot achieve secant x plus tangent x. At this time, let us try to manipulate the second side, the right hand side as well. So we will have secant x, which is 1 over cosine x, right? Plus, you will have tangent x, which is again sine x plus cosine x. Okay? Now, if we're going to combine that, okay, this is the left hand side. Let me just separate the two. This is the right hand side. So since you have the same denominator of cosine x, copy that. You will have 1 plus sine x here as its simpler form. But this is not yet the same as this. Right? What do we need to do here is to pair them into one equation since they are actually of the same equation earlier. So the left hand side, okay, becomes cosine x over 1 minus sine x. Okay, this is the entire left hand side in simpler form, equal to our right hand side is 1 plus sine x over cosine x. Again, they are not necessarily the same. What we could do here is to use since they are both rational expressions, they behave like fractions, we can use here the fundamental law of proportion. Okay, this means that if this is really equal, the product of the means is equal to the product of the extremes. These are the extremes, the numerator here and the denominator here, and these are the means. Or in short, in your simpler process, cross multiplication. If the product, or after multiplying, are just equal to each other, then we have established that these two are of the same proportion. So let's try to multiply that. Cosine x times cosine x. You will have cosine squared x, right? Okay. The other side, you'll have 1. Okay, take note of this. You will have binomial expression. You will have binomial expression 1 minus sine x, okay, to be multiplied with 1 plus sine x. Sorry for this, don't have much space. Okay, so when you check that one, that's cosine squared x. You are multiplying binomial expressions of the same first term, the same second term, but they differ on their operation separating the terms. We have difference of two squares, so 1 squared is 1 minus sine squared x. Okay? You can of course multiply that further if you would like to. The question now is, are these two the same? Now notice we have one of the important trigonometric identities, specifically Pythagorean identities, is in this form. Sine squared x plus cosine squared x is equal to 1. Okay? This is one of the Pythagorean identity that is actually taken from the unit circle. Now if we're going to subtract both sides by sine, meaning subtract the sine here, you're left here with cosine squared x is equal to 1 minus sine squared x. In short, look at this one and that one. By the Pythagorean identity in the fundamental law of proportion, we can say that cosine squared x is just 1 minus sine squared x, or 1 minus sine squared x is just equal to cosine squared x. In short, we have here the cosine squared x is equal to, let me separate these portions here as well and this as well. Okay, so we have here 1 minus sine squared x, this is squared by the way, sorry, is equal to cosine squared x. Since we have arrived to this, we can now say that this ratio and this ratio are in a proportion. They're equal to one another. And take note that this ratio is originally the left-hand side of the equation, and this is the original right-hand side of the equation. At this time, we have a lot of processes, but that's what will happen if in the first step of simplifying either side, we will have forms already in simpler form, but they are not yet virtually the same. So this is now the proof that for this case, we have the identity of the two expressions. This case for missing identity is now closed. If you may, to be ready for some new cases, subscribe now.